Hello everyone, welcome to Mifratech. Today in this section we are going to see the demonstration of facial landmark detection using Opencv and eLearning library. So in this project we are mainly going to detect facial features like eyes, nose, mouth and facial face jaw. So we are going to in this section I am going to run the code and I am going to explain you the code in detail and I will show the output. Okay, before starting with the code, so to to run our code you can use any Python IDE. So in this I am using Python IDE, that is 3 in the version 3.68. So first the main libraries which we required for this project to run is one is Opencv library, that is an important machine learning computer vision library which will mainly helps in the like image manipulation, image capture and image related operations, and also the video related like object detection, we, video capturing and video manipulation techniques. And one more library is dlib, that is a dlib library is mainly used for the purpose of face detection and face you have to detect a shape of the face and face detector. Those modules will be available in this dlib library. So first we have to import these two libraries in your system. So yeah, for the installation of these two packages I have made a video, you can watch that to know how to install any packages. So after installing these two packages in your command prompt, you can use the pip install opencv and pip install dlib commands to install these packages in your system. After the packages have been installed successfully, you open any Python IDE. Later, first what you have to do means you have to import those two libraries to run the code. First, in the first line I have imported import cv2, that is to import Opencv library. Next line I have import dlib. This line indicates the importing the dlib library or package to our code. After importing these two libraries, I have to load the detector. As I told earlier, we have to load the inside the dlib library we have inbuilt modules for facial detection and shape predictor. So those two modules we have to load first. So in the next line, the detector is equal to dlib dot get underscore frontal underscore face underscore detector. So this module which will be inbuilt in the dlib packages will detect the faces from a video or any image. So after loading this library, we will store it in the variable detector. After loading the detector, we have to load the predictor. So to predict the shape of the face, have to predict on shape, the shape predictor, which is we already inbuilt module in dlib library. For that we have to use the command predict, that is predictor is equal to dlib dot shape underscore predictor of. Inside that have given a which shape predictor data set data set which I am using, that is shape underscore predictor underscore 68 face landmarks. So .net. So this is the file which contains the various 68 landmarks which are available in our face will be made as a data set. So that we have to load for the shape predictor. So after importing this library, I have assigned it to a variable predictor. So we'll see what is this shape underscore predictor, like 68 various landmarks in our face. Okay, as you can see in the screen, these are the different 68 points or coordinates in our face which will detect various, which will indicate various features of our face. So from 0 points from 0 to 16 it indicates the facial jaw of the face, and that 17 to 21 point indicates the left eyebrow, and 22 to 26 indicates the right eyebrow. Then from 36 to 41 points will indicate a left eye, and 42 to 47 indicates right eye. Then the from 27 to the total, that for 35 whole indicates the nose, and from 48 to 56 you can see that is the outer mouth, and this whole thing indicates the mouth, and total from 48 to 67. So there are total from 0 to 67, total 68 points like different points in the face, which will indicate the different spatial landmarks or features like eyes, nose, eyebrows, and mouth. So by you, so this points are like each points will be represented as xy coordinate. So this will be stored in that input data set which I have imported. So I will show you how that file look like. As you can see in the file explorer, there is a data set called shape underscore predictor underscore 68. So face.landmark.data. So this data, that file you have to download, and you have to use this in your code in order to predict the shape. So after the face has been detected, so we'll see. So again, get back to the code now. So after it has been loaded file, so we will assign the predictor to the variable predictor. After the detector and predictor has been loaded successfully, have to read the image, means have to capture image or a video by using this Opencv library using our webcam in our system. So for that, the command is, I have already imported Opencv library. So cv2.video capture of 0, this line will open your webcam inbuilt in your system. So it will capture your video. So that captured like webcam opened, that captured video will be like captured in a frame by frame. So that will have stored in the variable cap. So here in this cv2.video capture of 0, as you can see, 0 means to to invoke or open a webcam present in your system. Instead of 0, if you mention the file which are already stored in your any video file stored in your devices, you can open that video file also, you just by changing this attribute. So in this project, mainly I am using my webcam to detect the different facial features. So for that only purpose I have given cv2.video capture of attribute 0, which will invoke or open the webcam present in your system. So after that, reading the video or image, I have to, like I told, video is nothing but a frame by frame like motion of the frame. So that frame will be coming continuously. So we have to store those frames. So for that only next line I have used infinite loop. So while true indicates the infinite loop. Inside the infinite loop, I have to collect each frame. So the cap.readof will collect the each from the video, it will collect each frame. So each frame after collecting reading, I am storing in the variable frame. So next variable there is a RET, you can see that will tells whether the frame has been successfully stored or not, detected or not. So the ret is a boolean variable which will tell only the true or false. If the frame has been stored successfully, it will tell true. If not, means it will tell false. So you can print this RET in separately and see whether the frame has been detected successfully or not. So that's the purpose we have used this. So it is a inbuilt variable in Opencv. So after the video frames are collected infinitely, we have to convert the colored, our webcam will detect the image in a colored format. So we have to convert into grayscale, like black and white. So why we have to convert into grayscale means, because to apply to image processing, colored image will be stored in like a matrix format in any system. So or any image. So it is nothing but a three-dimensional. As you can see, colored image is composed of three colors, mainly BGR. So blue, green, and red. So those each will be stored in single matrix. So it is like a 3x3 matrix, you can say. So handling that much of information will make it very will reduce the will slow the process of this recognition. So we'll convert the three-dimensional into single dimensional. That is, we'll convert colored image into a gray image, and grayscale image nothing but black and white image. For the process of to increase the efficiency of the process. So to do that, there we have a inbuilt module in Opencv, that is cv2.cvt color. As you can see this, so this module or a command will convert we can change the color of the original image. So here source I have taken as a frame, so that each frame which I have collecting from the video, that I am given as an input attribute. Then you can see, so we have to code. There is a variable attribute. Code is nothing but, so from color to black and white, like grayscale, you can have to convert, or from grayscale to colored image. So that color coding conversion have to give here. So code I have given cv2.color underscore bgr to gray. So here I have changed from like blue, green, red, the colored image to grayscale I have converted. After the image has been converted, each frame has been converted successfully, I have stored using the variable gray. So after the frame has been converted into grayscale and I have stored in a gray image. So next step have to like detect the landmarks in a face. So for that, I have loaded the detector which is available in dlib package. So that have to use now. So I have used a detector of gray. So for detecting the face, the image which I like converted into grayscale, that I have given as an input for detector. So the detector will detect the faces. So it will continuously detect the faces. So each faces which will detected by the detector, we have stored in the using the variable faces. So as face, it will not like faces is nothing but it mainly, like if you consider the face will be enclosed in a rectangle box. So I have to take all the coordinates like x, like left, top left and right bottom, all those points. So first for that I have used a for loop for face in faces. So like each time it captures the face, for in that faces have to save the coordinates for the later purpose to, because I have to indicate all the 68 different landmarks, facial features in my like video or in image. So for that purpose I have to store the coordinate values. So next line I have indicated x1 is equal to face dot left. So the left coordinate value will be stored in x1. Similarly face dot top, so the top coordinate value will be stored in y1. Similarly x2 face dot right, so the face dot bottom will indicate y2. I have stored it in y2. So after the left, top, right and bottom point, all the point has been detected. So the whole indicate the face. So after storing all those values, I have stored in using x1, y1, x2, y2 variables. So using those variables, let me indicate or predict the landmarks in our shape. For that, so we have to create a landmark object. So for that I have used up, like already have imported, like load the predictor which is available in dlib package. So using that predictor of have given image, the input as a gray image which I have converted. Here for box I have gave it as a like face, that which faces every time we detect, that will be given as a input. After the creating a landmark object, have to loop through all the points. Like there are, as I shown in the image earlier itself, there are total from 0 to 68 points available. So in order to detect like all those points, have to loop through each and every single point from 0 to 67. So I have used a for loop for n in range of 0 to 68, means from 0 to 67 points it will take. So every time I take a point, that will be assigned to, like for a predictor I have used I have created a landmark object already, so that is available in landmarks. So from that landmark, that part of n, so in that n, if I every time it will take starting, it will take landmarks part of 0 dot x, that will be assigned to x coordinate, x value. Next landmark, that part of again 0 of dot y, that will be assigned to y. Every time x and value from 0 to 68, all the values it will take. After taking all the values, we have to, like all those points, we have to to indicate every point. Here drawing a circle as a point. For that we have to use the inbuilt function in Opencv, that is cv2.circle of, for which value we are drawing a circle, means each every frame image. From that, for drawing a circle, we have to mention the coordinate, that point, that is center x comma y, which will indicate from every point. After that we can mention whatever the radius of circle we want. For that radius, I have, in this example I have taken radius is equal to 3. So you can give whatever value you want. So then color, you can see one more input, that is nothing but in which color you can show every point in our face, the final output. So in this example is here 3, you can see 0 means blue I have given 0, 255 for green I have given as 255, and red I have given 0. So now my final output will show each landmark position like point in green color. So you can change it according to whichever desired output, in which color you want in your output. So I can also give like thickness. Here given thickness is equal to -1, which is nothing but, if I given thickness like -1 means the circle will be like a solid circle, so that inbuilt inside the circle also it have filled with green color. If I give it as a 1 means it will be like a hollow circle, so you can change according to your wishes. So after that drawing a circle, you have to see the output. So to see the each image output, you have to use the command that is cv2.imshow. This is the inbuilt command to show the output in the Opencv. After what we have to show means every frame, after doing all this like prediction, detection and prediction, we have to show each frame. For that I have given a frame as a output, so this will be available, this will be showed in the output. So after showing the output, so we have like the output is continuously displaying on the screen. So your video, like it will detecting the each facial landmark. So by using, so we have to when if you don't want to see the output, to escape from that output window, we are using if of cv2.wait key of, like we can set how much long or how long that video like output should show, so that we can give it in the delay. So here after that we can also set that as you can see, wait delay of 1 I have given like 1 millisecond, not 1 millisecond, it's 0.11 millisecond. After that I have equal is equal to 27. Here the 27 is nothing but it is the ASCII value of escape key. So in this like in this project, if the output is showing continuously, if I just to escape the to exit the from the output window, I just have to press escape key. So only that purpose I have given value is equal to 27. You can set it also as you like you wish, which button you have to press to escape from the output window. After that we have to, like after everything showing, we have to release the window. So like nothing but have to release the video capture and video write objects. For that we have used cap.release. It is an inbuilt function in Opencv library. And after that, showing every output, we have to like close the windows. To close all the windows, we have used cv2.destroy all windows. So using this command we can close all the windows. So this is the code for like detecting each facial landmarks and facial features like nose, mouth and jaw in your face. So so let's see the output by running this code. So we'll run this code. After we run this code, we can see our output. I will show you. We'll see our output. Wait, we'll run this code. Whenever like after writing the code, if you run this code, first it will like your webcam will open. So you can see like a light indication your webcam. So after the webcam has been opened successfully, so you will get an output window which will be showing your resultant detection. So you have to, like if you are not set it as a predefinedly for your output, like you have to give allow for input. So I will show you the output now. So I think you can see in the window now. This is how your final output will look like. So just by running after that code, you can see our output will be indicating every each and all 68 points, like specific 68 point coordinate points in your face. So you can indicate a face, jaw, and then mouth, nose, left eyebrow, right eyebrow, left eye, right eye. So this how efficiently it will indicates each facial landmarks using this code. So this can be used in many